Good morning. Today we're going to look at section 5.2a. Our target today is to determine relative maxes and minimums of polynomials. So yesterday we briefly mentioned the idea of turning points. We call those maxes and mins depending on which way they turn. So far for a given polynomial, we should be able to put it in standard form, name it by its degree, by its number of terms, and describe its end behavior. Today we're going to learn how to describe a new feature of the polynomial, the maxes and mins. You've already learned to describe the max or min of a quadratic when we talked about the vertex of that parabola. But now we're going to get the calculator to help us do this. So go ahead and grab your calculators or open up the TI-84 app on your Chromebook. All right, so talking through the process, the first step is to graph the function. So we're going to type that in our y equals screen. Okay, and then we are going to look at our graph. The next step would be to go to our calc key on our calculator. So we hit second and then the trace key. We'll work through this in just a second. And then we're going to choose the minimum or the maximum depending on what we're trying to find. Okay, and what we have to do with our calculator is basically tell it where to look on our graph. So we have to set a cursor to the left of our low point and to the right. And we have to do it in that order. So if this is what I consider my lowest point on my graph, I have to put a cursor somewhere over in here on the left side and another mark over here on the right side. And basically I'm telling the calculator, look between these two x values. Okay? So look between these 2 points and figure out where it hits the lowest value. Okay? So let's try one. Our first graph, we're going to put in the equation y equals x squared minus 2x minus 8. So on our calculator, we hit our y equals screen, and we type in our function. We have an x right next to our alpha key, and then we want to hit the square key. And then we need negative 2x, or minus 2x, I should say, minus 2x minus an 8. Okay, now, depending on what you graphed, the previous graph, you might want to reset it. Zoom 6 will set it to a standard window in case you've moved it around. All right, so we see the same picture that we had before, and we are trying to find this low point. Okay, so we're going to hit our calc key. To get that, we have to do second trace. And we are going to find a minimum value. So we're going to choose option 3. We can either just type the number 3 or you can arrow down to 3 and hit enter. Okay, now notice down here it says left bound. Okay, it's asking me to identify where I am to the left of my minimum value. And my cursor right now is in a pretty good spot, just as it is. But you can use your left and right arrows to move it around. Doesn't really matter how close it is, you just don't want to be right on top of your lowest point, but you don't want to be so far away that it takes your calculator a long time to calculate it. Okay, so somewhere there is fine, and then we hit the enter key. Then we notice it has changed to say right bound. So now we're going to arrow around past that lowest point. Again, we're going to hit enter to kind of lock it in there. And you will notice at the top here, you have 2 little marks. It's going to say I'm looking between those 2 values to find the lowest point. Now, it's asking for a guess here, but you don't have to do that. You can just hit enter again, and it's going to give you the minimum value. So it's telling me the minimum occurs when x is 1 and y is negative 9. So we would say our relative min is positive 1, negative 9. Okay, let's try another one. This time we want y equals x cubed plus x squared minus 6x. Giving you a basic picture of it here. So notice on this one we have both a maximum and a minimum. They're called relative max and mins because our graph does go higher than this point and our graph goes lower here than this point. But that's why they're referred to as relative. They're not an absolute max or min, it's just a turning point. So the process for finding a relative maximum is basically the same as finding a relative minimum, except you're going to choose option 4. All right, so let's try on our calculator. Go back to our y equals screen, clear that one out. And our equation was an x cubed, so we're going to hit our x key, and then this is our power key, and then we type the number 3. Okay, now notice I'm still up in the power, so I have to arrow over to get back down to a normal part of my equation. Then I need plus an x squared and minus a 6x. Okay, so again, we're going to graph that, and we're going to find our max and mins. So second trace, it doesn't matter which one we find first. We'll go ahead and do our maximum, number 4. I have to arrow over and make sure I set it to the left of my highest point there. Hit enter. And then arrow over to past that turn, hit enter again, and then hit enter a third time to bypass the guess. So our maximum is x equaling negative 1.786 and y being 8.209. Okay, then we can do second trace. This time we're going to find a minimum. So we'll arrow over here, mark left of where it's low, hit enter to mark that, arrow around the curve with your right arrow, hit enter again to mark that spot, and then we hit enter one more time. So our minimum value is 1.119 or 1.12, and y being negative 4.06. All right, sorry, I grabbed the wrong set of notes. There we are. Okay, so you'll see that we got the same values here that we were just talking about. All right, it says the design of a digital box camera maximizes the volume while keeping the sum of the dimensions at 6 inches. If the length has to be 1.5 times the height, it can be modeled by the equation y equals negative 3.75x cubed plus 9x squared, where y is the volume and x is the height. What should the dimensions be to maximize the volume? So this is a picture of the graph of this equation. Okay, we have a minimum, a relative minimum here of 0. And remember we talked about x being the height. So this is the height dimension, and this is our volume. So if our height is 0, we have 0 for a volume. That makes sense that we're at the origin. Okay, we are looking for a maximum volume. We want to find this highest point. Okay, so grab your calculators and enter this equation. All right, our equation was negative, and on a graphing calculator, be careful because your negative sign is, we're very picky about that here. Our negative is down here next to our enter key. So we want negative 3.75 x to the third, so x power 3. Remember, you have to arrow back down. Then plus 9x squared. Okay, we're going to graph it, and we want to find that max. So second trace, this time we're doing a number 4, maximum. I'm going to arrow to just to the left of my max, hit enter, arrow around the curve, hit enter again, and enter a third time to bypass the guess. So my maximum occurs when x equals 1.6. My y value is 7.68. And they asked us to find the x dimension. what should be the dimensions to maximize our volume? And we found that x had to be 1.6. So that is our height. And then it says the length has to be 1.5 times the height. Okay, length has to be 1.5 times the height. So my length is 1.5 times 1.6, and that ends up being 2.4. So I have a height of 1.6, I have a length of 2.4, and it told me that the dimensions all together have to have a sum of 6 inches. So if we take 6 and subtract our 1.6 for our height and subtract our 2.4 for the length, we should find what the width would have to be. Okay? Well, 1.6 and 2.4 is the same as 4. So we're really taking 6 minus 4, so we get a width of 2 inches. So our dimensions are 2 inches, 2.4 inches, and 1.6 inches. All right, let's put it all together. Our last equation here says y equals x to the third plus 2x squared plus 2. We want to put it in standard form. In this case, it already is in standard form, our highest power down to our lowest. Naming it by degree, our degree is 3, so it would be called a cubic. Naming it by number of terms, we have 1, 2, 3 terms, so we would call this a trinomial. Now for the end behavior, remember we focused on that first term. We have an odd degree. So odd degrees, remember, go in opposite directions. And our leading coefficient is just a positive 1. So think of a positive sloping line. So our end behavior, on the left, it's pointing down. And on the right, it's pointing up. All right, let's go ahead and find any max or mins for this. So back to our calculator. We're going to enter our equation. We have an x cubed plus 2x squared plus 2. All right, we'll graph it. And they asked us to find the max and min. So we're going to find this point. We'll do that one first. That's our relative max. Second trace, number 4. We want to set our cursor to the left of that, hit enter, move it around to the right of it, hit enter again, and hit enter a third time to bypass our guess. So our maximum would be negative 1.33, and our y-coordinate would be 3.19. We'll just round to hundredths. All right, to find our min, second trace again. This time we're going to choose option 3, minimum. And we're going to move our cursor just to the left of our low point and lock that in. Move it around that bottom point, lock it in, and bypass our guess. Now, notice here our minimum is negative 1.370. Sorry, negative 1.378e negative 6. That means that that is 6 spaces, our decimal is really 6 spaces to the left. So when you see something like this, we're really saying our x is just a 0, and our y is 2. All right, so let's put that down in our notes. Our maximum and minimum. Our max we had was negative 1.33 and 3.19. And the minimum that we found, our x-coordinate, remember that e to the e negative 6 is really saying times 10 to the negative 6, which is a very, very tiny number, basically 0. And our y-coordinate was 2. All right, I am going to have you flip in your notes packet to section 5.3e. We're going to look at that real quickly today, or parts of it anyway, because what we've been doing today is finding max and mins, and the process here for finding zeros is the same thing. So we are going to graph our function. We're going to go to second trace to our calc, but this time we're going to look at option 2, which is to find a 0. Okay, so we found this relative min before. Now we're looking for these points. Where does it actually hit the x-axis? Okay, so let's try x cubed minus 4x squared minus x plus 5. All right, let's grab our calculator. All right, let's enter our equation. We have an x to the third, so x power 3, and then minus 4x squared, minus an x, and plus a 5. All right, let's look at our graph. So we want to find all 3 of these zeros. Okay, that one, and that one. We'll just go through them one at a time. So second trace, this time we're choosing option 2, a 0. We're going to do the same thing. We have to set the cursor to the left of where we hit the x-axis. Lock that in. Move it to the right of where we hit the x-axis. Lock that in. And then bypass our guess. So that one is giving me a value of negative 1.094. Our y-coordinate is 0. That's what we're trying to find, right? Where y is 0. Let's do this again. Second trace, option 2. We're going to arrow over. This time to the left of where I cross is actually above the x-axis. And then I keep arrowing to the right and lock it into the right of where I cross the x-axis. And then bypass my guess step. My 0 is 1.163. Okay, one more. Second trace, number 2. We have to move to the left of where we hit the x-axis, right about there. Hit enter. Move it to the right. Hit enter again. And enter a third time. So my third 0 is 3.931. All right, let's go ahead and write those down. So my first 0, my x was negative 1.094. My second one was 1.163. And my third 0 was 3.931. So finding zeros is really the same as finding max and mins in terms of the process to use our calculator. But zeros are, we're looking for where we actually hit the x-axis. All right? In other words, where y is 0. So on your homework today, I'm going to have you add finding the zeros to each of the questions. So it's going to ask you to find max and mins. I also want you to find the zeros for those.